Okey doke. Make sure it's not, there we go. Okay, so thank you for joining me again. This is 8th grade 7.2.4. What else can slope tell you? So we've been working with slope the past few weeks, and we're kind of getting into more about it and what else can it tell you. So it reads, in recent lessons, you've learned how to find the slope of a line. You've also learned how slope describes the rate of change and the steepness of a line on a graph. In this lesson, you'll learn about other information that the slope of a line can tell you. I did not assign this problem, but it is like the first problem in the lesson. I think it's kind of like a little warm-up. And it reads, which is steeper, a line with a slope of 2/5 or a line with a slope of 5/2? And how do you know? So if you can think in your head or pause the video here as to what you think the answer might be. But I am going to use my reasoning that we talked about slope, like the bigger the slope, the steeper the line. And if I were to order these fractions least to greatest, or put a greater than or less than sign in between them, I know that 2/5 is a lot smaller than 5/2, because 5/2 is actually greater than 1. It's what, 2.5? So this is smaller than 1, so 2/5 is less than 5/2. And that means that 5/2 is going to be a steeper line than 2/5, because the bigger the slope, or the greater value the slope is, the steeper the line will be. So this would be maybe like this, and this would be like this. So that would be steeper than that one. So that's kind of a little warm-up problem. We're going to start with 768. And I'm going to have to move the camera a little bit sometimes to show the screen, because we do have graphs that we need to look at. So it says, we are already dealing with a graph. Compare the two lines in the graph to the right. And it's asking, A, how are the two lines the same and how are they different? So I'm actually going to bring you to the graph because it's easier that way. Woo. Oh gosh. Come on, there we go. Okay. So 7-68, compare the lines of the two graphs. How are the two lines the same? How are they different? So here's the graph. And what I noticed how they're the same is that they both intersect the y-axis at this point. So they both intersect the y-axis at 0, 12. So you go 0 and then up 12, and they both intersect at that point. So that's what I saw was the same so far. And how are they different? I'm noticing the slope. So I'm trying to, here, do I have a pen? Yeah. So the slope is going to be, for line A, if we were to use our finger and just go up 1 over 1, nope, doesn't work. Up 2 over 1, oh, it works. Up 2 over 1, up 2 over 1, up 2 over 1. So it looks like line A has a slope of 2 over 1. So let's look at B. It looks like it's going down, and it is. So down 1 over 1 doesn't work. How about down 2 over 1? Down 2 over 1. Looks like it works. Down 2 over 1, down 2 over 1. So it looks like A has a slope of 2 over 1 and B has a slope of -2 over 1. So that's how they're different. All right. For part B, it says each line on this graph describes how much money a person has in his or her wallet over time in days. Explain what is happening to the amount of money each person has. Be specific. So it looks like person A, here's person's A money going up, and here's person B's money going down, because the money is the Y and the X is the time. And it looks like the person A, the money is increasing because it's going up. So I put that person A's money is increasing $2 a day, and then it looks like person B money is decreasing by $2 per day. And I'm just using the slope for that number too, because I know the slope is 2 over 1, 2 over 1, 2 over 1. That means $2 per day. -2, -2, -2. -2 per day. That's what I put for B. Part C says, to describe how person A's amount of money is changing, the unit rate, the slope, represents the amount that is added each day. Since the value of money is increasing, the slope is positive, but what should you do when the value is decreasing? How should the decrease be reflected in the rate or the slope? So that's just a bunch of words to ask, how could you describe the slope of B? How could we reflect it in the slope? So I already kind of did that when I said, okay, well, A is positive 2 over 1, 2 over 1, 2 over 1, and I said that B was a -2 over 1, -2 over 1. So that means the answer for C, I just put that we could represent the decrease with a negative symbol. And that shows decreasing. All right, where's my mouse? Oh, there's my mouse. Okay, going down to D. So it says, remember that the slope ratio compares how the change on the y compares to the change on the x. Lines that go from left to right, up from left to right, show positive rates of change or positive slopes, while lines that go down from left to right show negative rates of change or negative slopes. And it says, find the slope of each line in the graph. And I kind of already did that when I reached the 2 over 1 and the -2 over 1 slopes. So I put person A, the slope was 2 over 1, and I wrote it just like that. And then person B was a -2 over 1. And that's what I wrote on my paper. And I'll try and show you. I wrote it right here. Person A, 2 over 1 equals, well, I put 2 because that can be reduced just to 2. And person B is -2 over 1, which is -2. All right, moving along. Whoa, where's my mouse? Okay. So here we go again with another graph, 769. So it says, what if it does not grow? The graph at the right shows 3 different lines. So part A, and here's the graph. Part A says, describe each line in words. Is it increasing or decreasing, quickly or slowly? So let's look at the graph, and don't make the same mistake I did, because I was looking at this graph and I didn't realize that B was its own line. I thought that was the x-axis. So I was like, why is there like a line down here when that's the x? I don't know why I did that, but don't make the same mistake I did. Okay, so it says, describe each line. Is it increasing or decreasing, and quickly or slowly? So I looked at A first, and I knew that it was increasing because it's going up to the from left to right, and it looks like it's going pretty quickly. It's pretty steep. So I described line A as increasing quickly. Line B, right here, it's that straight line, horizontal straight line. I put that it's not changing at all because it's not going up, it's not going down, it's literally just a horizontal straight line. So I put line B is not changing at all. And then line C, I'm noticing that it's going down to the right, so it's decreasing. And it looks like it's going slowly because it's not that steep of a line. So I put that line C is decreasing slowly. So here's my paper. I put line A, line B, line C. Okay, so that was part A. Part B says that line B is different from the other 2 lines. As the x value increases, what happens to y? So let's look at B. So as x increases, so as x goes from 1 day to 2 days to 3, 4, 5, 6, 7, 8, 9, 10 days, what's happening to y? Nothing's happening to y. I put that there is no change happening to y, because if there was, then the line would either be going up or it would be going down. But there's literally no change at all. So that's what I put for B. Part C. Slope is a comparison of the change in y over the change in the x. Pick 2 points on line B How can you use a number to represent the change in y between these 2 points? Use this number or the change in y to write a slope ratio for line B. So what I did is I picked the points. It said pick 2 points on line B. So I picked points 0, 4. So here's where 0 is. And then I went up 4. So I put 0, 4 as one of my points. And then I put 1, 4 as my other point. So over 1, up 4. And I noticed when I wrote these down, so here's what they looked like. 0, 4, and 1, 4. And the change in the y, you'll notice that there is no change in the y. So if there's no change, you represent that as 0. And then the 4 is the y-intercept. So that would be on the bottom. So I put the change can be represented as 0. The slope ratio is 0 over 4. So there's 0 change in the y, and the x is at 4. Yes, sorry, I was second guessing myself there. Yes, okay, sorry. All right, let's see. Part D says, recall that the units for the change in y are the same as the y-axis, and the units for the change in x are the same as the x-axis. What are the rates of growth for lines A and C? So it's asking us for the slopes of A and C. So I noticed that part A, I did a couple trial and error here. So I looked, it goes up 2 over 1, but then it doesn't do a nice even one again. So I just noticed that this went all the way up into the right 3, and it intersected right there at the grid. So I went from 5, 1, 2, 3, 4, 5, 6, 7. So up 7 and over 1, 2, 3. So I represented that as 7 over 3, $7 in 3 days. And I'll show this on my paper in a second. So line C, the line is going down. So I know it's got to be a negative number. And it looks like it's going down 1 over 3. Down 1 over 3. Nope, it doesn't work. So I had to pick exactly what I did with A. I just went down until I got to the line where it was intersecting. So I went 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So down 3 over 10. And I will show you what these look like. So this is A slope, $7 over 3 days. And C was negative 3 over 10 because you go down 3 and then to the right 10 for part D. Okay, where's my mouse? There it is. Express the rates, so this is part E, express the rates in part D as unit rates. So it wants us to express these 2 rates with a 1 underneath. So the only thing you have to do to figure that out is just to divide this number by this number and this number by this number. So if you divided 7 divided by 3, I'll show you what I got. I got $2 1/3, so about $2.33 per day. And I just plugged that into a calculator, 7 divided by 3. And then for C, I plugged in 3 divided by 10, and I got 0.30, so about 30 cents a day in the negative. So negative 30 cents a day. That should say C. Sorry about that. Let me see. No, that was not B, that was C. That was line C. So line A was $2 1/3 per day, and line C was negative 30 cents a day. Whew. All right, then. Okay, last problem, 770. Personal trainer. To prepare for biking long distances, Antoine has been trying to keep a steady pace as he bikes. However, since his hometown has many hills, he ends up biking faster and slower during different parts of his ride. To track the distance and time when he trains for the triathlon, Antoine purchased a special watch that tells him how far he has traveled at specific time intervals. With the push of a button, he can set it to record data. Then at the end of his workout, the watch gives him a list of the data. So there he is, checking his watch. And where's my mouse? There it is. So here's his data in a table. So now, part A says, on his first bike ride around town, he recorded several times and distances. These measurements are shown in the table above. According to the table, does he appear to be traveling at a constant rate? And explain your reasoning. So, is he going at a constant rate? Is it going at a rate where if we times this number by something, it would be the same going all the way down? And what I saw was that it looked like there's not a constant rate, because if we look at, okay, so I figured out what was going on here. So CPM gave me an answer that I didn't really like very much, so I came up with my own justification. So no, he's not going up at a constant rate, because here's our x, here's our y. If we were to divide this number by this number, you'd get a value. And what I got was 0.16667, whatever. Then I divided 1 divided by 5, and it was 0.2. 2 divided by 8 is 0.25. 3 divided by 12 is 4. So those are all not consistent. So that means he's not going up at the same rate. If he was, then every single one of these numbers, if I divided this by this and this by this and this by this and so on, would all have the same rate, the same value every single time. Okay. Now, so he's not moving, he's not going at a constant rate. So now it says draw label a graph that extends to 40 minutes on the X and at least 15 miles on the Y. Plot Antoine's time and distance data on the graph. So I took the points, and I just started plotting them on this graph, and I'll show you what it looks like. And so here's what it kind of looked like. So I did my Y-axis by 5s, and it said to do it up to 40, and I did my distance by 2s, and I did that up to 20, and I think they said 15, but I did 20 anyway. So then I started to plot them, and that is my first point, second, third, fourth, and they weren't very straight in a line, so I knew that this was a scatter plot, and it wasn't just a linear line that can be connected by all the points. And that's actually kind of what the next part gets into. So part C says, draw a trend line. I was going to make spaghetti. Draw a trend line that best represents Antoine's data. Then extend it to predict how long it will take him to bike 10 miles. So here's my trend line. I did a trend line kind of through the points evenly, kind of. But the trend line doesn't have to go through the points. It just has to be kind of the trend, the pattern of the data. Okay. So then it says predict how long it would take him to go 10 miles. So if I go to 10 miles is up here, and then I go over to the line. Whoa, I need to do this with like something straighter. Maybe my pinky. Okay, so here's 10 miles. And here's, I'm going to draw it out to the line. So I have it about here where my pinky is. And that's about, I don't know, like 35 minutes. Did I do that? I put 35 minutes for 1 mile. So, and sorry, you're looking at part D, so you see the answer already. So it's about 35 minutes for 10 miles. And part D says, what is his general rate during his bike ride? Find the slope of the trend line that you drew in part C. So it looks like it's kind of going, for every mile, it looks like it's going up 3 minutes. So there's a mile going over 3, mile going over 3. So that's kind of what it looks like. I think that's what CPM came up with too. Yeah. So here's CPM's graph, so it kind of matches mine. And his rate, where did it say part D? Part D. His general rate, find the slope of the trend line you drew. Yeah, so about 1 mile takes him about 3 minutes. All right, I know that was kind of a messy-ish lesson. Hopefully you stayed with me, and I will see you in the next video. Bye.